analytics startup company building its center of excellence in Bangalore. He is passionate in teaching and has been actively involved in conducting sessions on analytics for Oracle University and Miles Education. So welcome Yasin sir, nice to have with you, and nice to also read that passionate in teaching. Yes, for a teacher this is very, very important. Yes, thank you. Welcome to you.
Thank you ma'am, thanks a lot. Thanks a lot everyone for taking time on Friday to join the session. So let me go ahead and share my screen. Can you confirm if you are able to see the screen now?
Yes sir, we can see.
That's good, okay. So the topic that we are going to discuss today is on growing impact of AI in financial services. So before we get started, can I request everyone to mute yourself? I can hear a phone in the background. So when you have any questions, feel free to unmute yourself and let me know your questions, and I'll be happy to take it. Okay. Feel free to stop me at any point of time. So I've scheduled this session for roughly around 40 to 45 minutes, and I've devoted the last 10 to 15 minutes for any Q&A. Okay. And at any point of time, if you have any questions, feel free to stop it. We can probably take quick questions, and if the question is going to take some time, then probably I will keep that aside for the last 10 to 15 minutes that I have devoted for the bigger Q&A. Okay. Or if you want to keep sending the questions in the chat, feel free to send the questions in the chat. We can collate it, and then I can take it in the end as well. Okay. I would allow this one to be an interactive session. The more the questions, I'll be more than happy to answer them. And this is primarily, I'm not going to take it technically. I'm going to try to take it to ensure that you understand it from the business side of it, and also from your career perspective, so that you can probably understand where we are heading towards, what is the impact of AI and business analytics, and how is it related to the financial services in general. Okay. So before we understand data analytics, it's important that we understand what is data. Okay. So data, if you had asked me 10-15 years back, I would have probably told that data is all the papers that you have stacked up in my files, and those files go into a cupboard, right? So that's all data. But in the last 15 years, we have undergone sea change in the way we collate data. With the advent of computers and then new processors and everything in place, the word data has undergone a lot of change. So it has its origin from data, which is something given. So you have a data, and then you have information. Is data same as information? No, certainly not. I always see that if you are stranded in the small boat in the middle of an ocean, you see water all around you. Okay, so that is data. You have data all around you. Right from the phone that you use, to whatever you watch in the TV, to whatever you see in the laptop, and whatever you hear from me, it's all data. Okay, whatever you take from data and then process it, just ensure that you have some kind of processor in your hand in the middle of your boat, and you take the salt water around you and then process it and then convert it into a potable water, drinkable water. That is information. Okay, so you might have tons and tons of data around you, and you need to have some kind of techniques to convert that data into information that can be used for taking business decisions. Right. So with the advent of technology, the data has increased manifold in volume and in the frequency in which it is being generated. Okay. So, but what has not coped up is how much faster you can convert the data into the information part. Okay. So that's where the data analytics comes into the picture. So what's the whole concept of data analytics? You take the data and then use techniques to convert the data into information, so that business can use that information to take good business decisions. Okay. The earlier business are taking decisions primarily based upon data. Now we are trying to make businesses cleverer, smarter, by making the businesses take decisions based on the information, not on the data. Okay. So any raw data, raw facts and figures that needs to be processed to become information is called data. Okay. So how has the tools evolved? We were having these tools earlier, and tools have evolved to a lot extent in the last decade. Okay. And how the sensors are evolved? Right from golden days, we have taken gargantuan steps. We have taken humongous steps in getting the progress on the sensors. So now we have unmanned UAVs who can go and collect the sensors on the Mars and then come back to you, right? They were the last one of the figure on the list, right? So sensors have increased a lot, sensors have improved a lot. So you do not have to wait on manual coding to get the data. You can have machines who can feed in data at any point of time, right? Computing power. So we started off with a simple desktop computer, and then you had the laptops, and then you had the cloud computing, and then you had supercomputers. Now you have everything on the cloud. You have now with parallel computing and everything. So your computing power has increased a lot. Earlier, whatever your desktop was doing, your phone can do it faster now than what your laptop or desktop was doing earlier. So once I was talking to my friend, he had a phone which was having around 200 gigs memory, okay? And there was my father who was having a 128 GB laptop, okay? So that was 20 years old. So that one side where we have laptops with 128 GB, and then we have a phone which is having 200 gigs, okay? The latest iPhone. So that's where we are heading towards. So with the evolution of data, with the evolution of tools and the computing power, we are able to take small steps from what we were doing earlier. We were actually reporting the past. We were actually reporting what has happened in the sales in the previous year, and we were taking business decisions on how to improve the sales this year, right? So that was what we were doing. So, and that is called business intelligence. Okay? And then came machine learning. What are we doing in machine learning is, yes, we know what has happened in the past. Can we predict what is going to happen in the future? Can we start predicting that? So machine learning was able to help you doing that. Then when the businesses could take decisions based upon suggestions from machine learning, that evolved into data science, right? So earlier we were only based upon only on the historical data. Now we were able to take into account a lot of other things apart from the historical data. Your environment, what's going to happen in the future, and all this stuff, and then you're going to predict what's going to happen, and then take a judicious business decision. So, like say for example, one of the best use cases is your Google Map, right? So when you step out of the home, and if you're going to click on your source and destination, your Google Map is going to tell you which route to take, right? So in the earlier times, just imagine that if you were in this world, where reporting the past, someone would have told you, this route is always crowded between 11 to 5, so try to avoid this route between 11 to 5, try to take the alternative route. So that was what the business intelligence world was doing. We knew from our previous experience that this route will be crowded, so take it. It does not check real time what's happening, right? So now in the machine learning world, what was happening was that based upon the frequency of how many times this particular route is going to be crowded, it's going to tell you there is a 70% probability that this particular route is going to be crowded, so you better take this. And say for example, if it says that this route is shorter by half the distance, but there is only 50% probability that this is going to be crowded, then you can probably decide to take the same route because there is still a 50% probability that it's not going to be crowded. There will be less traffic, so you will probably take that. That is what predicting the future, the machine learning was trying to do. It was trying to put some numbers on top of the business intelligence and predict what's going to happen. Then came the decision making using data science. That's what your Google Map is doing. It takes the data real time and tries to tell you at this point of time, this route is not having traffic. Even though in the past this route would probably be having traffic, at this point of time, this is the shortest route and this is going to be the best route that you can take. So it automatically routes you to the best possible route available. So most of the data analytics platforms, applications, products that are there available in the market is currently here. We have moved from business intelligence to machine learning to data science. And the final step that all the products are trying to get into is artificial intelligence. So that is how the machines are going to think on its own and take a decision on its own, so that that's going to be best for you. I know it's very scary, but that's where all the companies and all the products are trying to get into. The best example, probably the only example that comes to the mind, is Tesla's driverless car, right? So you do not give any information to the car. You do not tell that you are going to take a right turn or left turn, or you need to put a brake in the signal or not. All that you need to do is go sit inside the car and it will try to reach your destination, and it will take care of putting the brakes, it will take care of the signals, it will take care of the routes, and it will also take care of the shortest possible route that you need to go from a destination to another destination. So that's what we are looking at from an artificial intelligence perspective, to make the transition from business intelligence world to the artificial intelligence world. Is it easy? Mankind has been able to make the transition from business intelligence to machine learning and data science successfully, but is struggling to make transition from data science to artificial intelligence. So Tesla's driverless car has been on the works for the last 1 decade now. So it's been like 7-8 years that they are working on it. They have still not been able to pilot it in some of the countries. So in US they have been able to pilot, but they met with an accident and they are not able to clear it. So they're still working on it, but it's still a long way from going live with artificial intelligence. But there are certainly areas where data science is useful very much, right? Like, for example, in the medical field, we couldn't have got vaccine created if not for the data science. So it helped a lot in creating the vaccines in short period of time. And also in the robotic surgery, instead of doing a full surgery, you can now do a pinhole surgery, because you do not need to have a surgeon's hands to do the surgery. All that you need to do is robotic arms who can do near precision surgeries instead of, and you obviously your doctor is going to be controlling what to do and what not to do in this place. You're not going to that place. You do not want to go to that place in surgery for sure. But in this place, the doctor is going to control what's going to happen, and the robot is going to do the actual surgery, right? So we are able to minimize the invasion, the cuts onto the body, so it's going to become cleaner faster. And we're going to ensure that because it's not human hands, you are trying to remove the manual, not the effort, manual mistakes that comes along with that as well. Okay, so there are manufacturing companies, airline industry, for example. One of the industries which has used data science to a lot extent is the airline industry. Earlier, when there was a delay in one of the flight, there was a full crash. We can see that all the other flights used to get delayed because of that, right? Probably if you have seen it 10 years back or something, at the moment one flight goes late, you can see that all the other flights will get delayed, right? You only see that. But now with data science, even if a flight time of a flight is going to be delayed by even a few seconds or minutes, the algorithm what it does is it creates alternative routes and schedules for all the other flights according to the available area, the bay availability. Okay, so you do not have fixed boarding gates for each of the flights now. So you can see that it gets rotated among the different flights and it will get reassigned quickly depending upon the availability. So it has helped greatly in airline industry and also in predicting the ticket sales. So you can see that airline industry, the tickets prices are always not the same. It changes, right? It starts off with a number and then goes up and then comes down and then goes up and then finally ends, right? So what is behind it? It is again data science over there. So data science predicts the demand for the particular ticket on the particular route and then fixes a price, and then on the go evaluates what's going to be the best price depending upon the demand. Okay, so that's worked well for the airline industry. They are able to cut costs a lot. So some of the other industries are also trying to introduce it. Now, Indian Railways has introduced this. What Tatkal is it called? I'm not getting the name, but there's a new Tatkal just.
You all know? They don't have an idea except sir. You got paused, no? Positive, huh?
The transfer because of the networks, storage, and just led to better decision making, okay, for the business. So, if you ask me where is data, data is everywhere around you, starting from the web that we browse to the retail shops where you collect the data, medical, science, space, financial, insurance data, telecom data, intelligence data, and your phone is a storehouse of data, right? And every person almost generates around close to 1 megabyte of data every hour. Okay, so that's how much of data that we are generating. Okay, so just imagine one person, and we are around close to billion of people. So that's how much of data that we are generating. Okay, so how big is the data that we are trying to generate? Like as I told you, by end of 2020, it was expected that we will be generating around 1.7 megabyte of information each second. So imagine. Every time you look into a YouTube, Google or Amazon, you are actually generating data. Okay, so just for an example, Google processes around 3.7 billion searches per day. Okay. That we are looking at. Okay, so that's why we call this big data. Okay. So what is big data? Big data has 3 V's: volume, veracity, and frequency. Right. So the volume, the size of the data that's being generated. The veracity is the information which is going to be valid enough. Okay, good information. That's called veracity, and also the frequency of the data. Okay. So volume, velocity, and the veracity. So velocity is going to be the frequency in which you are generating the data. It has increased huge. You're generating 3.7 billion searches per day, right? So that's humongous data that you're going to be generating if you want to take into consideration a month for information for your project. Okay? So we need bigger storehouses for us to process data. We need new technologies to process the data. So that's where data analytics comes into place and cloud comes into place. So 2 technologies which is going to be in demand for tomorrow for all students is going to be cloud. So if you're looking at doing any certifications, do AWS certifications, do Azure certifications. They are going to be really valuable. And if you are looking at learning of any new technology, learn data analytics, it is going to be in demand for the next decade for sure. Okay, so if you want to learn any programming language, don't learn C, C++ or Java, go and learn Python. Python is going to be the most sought after programming language, at least for the next decade. Okay, so with the advices aside, so we have data. We know that there's huge data and a huge volume of data and the velocity of data. So what next? I have some data put together here. I already put something into the spreadsheet. Can someone say can someone say something about this data? If I ask someone, can you tell something about this data, how are you going to tell something about this data?
Actually, we are not able to see, sir. Yes, can you see the data? It's very small, sir.
Oh, that's okay. I just put few numbers over there. Okay, so numbers from 1 to 10. I put some numbers over there.
Yes, what you can see. Sir is asking that what exactly you can understand from that.
If I ask you to say, can you tell something about this data? What can you say?
Yes.
Something about it. There's nothing wrong, right or wrong.
Anybody can say. You can tell something or you cannot tell something. Sorry. Louder, yeah.
Sir, it's raw data.
Louder.
It's raw data, sir. Basically,
It is raw data, certainly raw data. It is not telling you any information.
Yeah.
So if I have to ask you, can you tell us something about the data? I am asking for information, right? I am not asking you to tell about the data. So if I am asking you to give me some information from this raw data, what can you do? Can you try to generalize this data to something?
Yes or no?
No? Okay, let me give you one hint, okay? So, when you get data, you will get data in this format, okay? But if you need to make sense out of the data and convert it into information, you need to try to see if you can put some sense out of it, right? So, there are 190 counts of this data. You can have probably counted and told that there are around close to 100 variables there, 100 data, right? And then you can probably done a sum of all the data. You can actually do a sum of the data. Then you can also do count of a particular value. How number of times 4 has come, number of times 5 has come, number of times 10 has come, and something like that. You could have done that, count of it. You could have also done a mean. You could have probably found the average of the whole data. Or you can also do a median. You can also do the median. And something else you can also do is find the range. What is the lowest value of this data and what is the highest value of this data? And the highest value minus the lowest value is going to be the range of the data. So this is called raw data and this is called information from the data. Okay. So how do we arrive from the raw data to the information? I'm just trying to put it very simple. How do we arrive from this raw data to this information? Is we use some kind of mathematical techniques, some statistic technique to convert the raw data to information. Okay, so that's what data analytics is about. Okay, so what is data science? It is a data-driven science. It is an interdisciplinary field which uses three main concepts. Okay, programming, statistics, and business knowledge, and tries to extract information or knowledge from the data. The data can be a structured data, it can be neatly arranged in the form of rows and columns in an Excel, or it can be unstructured data, like say for example your WhatsApp messages, your text messages, your comments in the YouTube, all are unstructured data. It does not have any structure to it. So you can have data in any format, structured or unstructured. If you want to use all these three techniques on that raw data and convert it into information, that is called data science. Okay? So this is my most favorite diagram. Okay. So what do I need to know to become a good data scientist? Okay. So you need to know programming, you need to know maths and statistics, you need to know the domain or the business knowledge in which you are working. It can be retail, financial sector, airline industry, travel industry, banking, anything that you want to. You need to pick up a domain and know the domain. And also you need to know a bit of programming and then you need to know statistics. If you are good enough in all three, then you will figure into a good data scientist. Okay? But is it easy to become good in all three or at least become decent in all three? No, it's tough, right? Because it's not easy to have all the three skill sets and we have our products, right? So what I typically see people become is that fall here, here, or here. Okay? So if you are good in domain knowledge and you are good in maths, you can go into the research for developing new algorithms. Okay? So you can fall into the research category. So if you are good in programming and you are good in maths, but you are not able to pick up domain, then you can create Python codes for machine learning. Okay? And if you are good in programming and you have picked up the business domain, you can create your applications for software development. Okay, so all these four are career opportunities in data science, but for a data scientist, he needs to know all three domains. If you want to pick up one among these three, then you want to be in your IT field. Like say for example, if you want to pick up only Python, you will probably see that here. Okay, If you're going to pick Python and statistics, you're going to pick it here. If you're going to pick Python, statistics and your business domain, then you're going to become a data scientist. So try to understand where your strengths are and where your weaknesses are, and try to upskill your knowledge in those areas. Okay, so that you can figure out where you can try. And I always find this problem when people apply for jobs. They apply for jobs irrespective of what is required, and they have one standard resume for everything. Okay, right? So you need to understand what the resume is, or rather the job is asking you to do. If the job is for software development, and if you want to have your resume telling that you're putting statistics, no use at all. I don't find any direct mapping at all. So if you are looking at applying for a software development Python role, for an application development role, put programming knowledge and the domain on which the company is working and mention these. Say for example, you are applying to Hindustan Unilever Limited, HUL, and you are applying it for a software development role. What I will do is, I will quote my manufacturing domain or supply chain domain knowledge, and also I will quote my programming knowledge, so that they will look into you and they will call you for interview. Okay, if you want to quote anything else, they are not going to call you for interviews. So similarly, you should know what to quote in your resume when you apply for jobs. Okay, so depending upon what the company is looking for, try to position your resume accordingly. Okay. So why data science? Now with almost all the domains are using the data-driven approach to take judicious data-based decision making. Okay, so travel I told you, and use case, healthcare I gave you in this case, and education I also. Education, the Byju's has been the latest front runner in data science world, right? So they have been using the data science to a great extent in the online application platform, learning platform. So they have used it really well. Okay, so and domains that have been using data science, I've already told you. I'm just going to repeat it: banking, insurance, telecommunication, healthcare, retail, marketing, chat boxes that you see in all the e-commerce sites or any site that you go to now, they have chat boxes. And sports uses data science to a large extent to analyze operands and to improve your performance as well. Okay, so you have all the domains open for you. So get yourself comfortable on a particular domain, improve your skill set on that, and then apply for your career. Okay. So what are the three different analytics that we do? We do descriptive analytics, and then inferential analytics, and then predictive analytics. So what is that? So descriptive is based on what has already happened. Inferential is what is going to happen, and predictive is you're going to predict what is going to happen. You're going to put a number and tell that with this error, I'm sure that this is going to happen, so that business can take decision. So each one of them is a separate domain, and these are all the different techniques that are going to be used for in the analytics world. Okay, I'm not delving into it. So quickly jumping on to the second part of our session, which is going to be our banking and financial services. There is a difference between banking and financial services industry. So banking is actually a subset of the financial industry. Financial industry is actually a bigger chunk. It consists of banking, credit card companies, investment firms, credit unions, everything. Banking handles money deposit and other financial transactions, and it also uses money deposits to distribute loans, right? So we know how the banking works. Financial industry actually is a bigger one. It encompasses insurance companies, gold loans, mortgage dealers, credit card companies, investment firms, share market, and also asset management. So all these fall under the financial institutions, and all uses data science. Okay. In the next 15-20 minutes, I'm going to quickly walk through some of the use cases that are used in the financial services. So there are majorly 4 or 5 of them. One is customer segmentation, next is profitability analysis, third is fraud analytics, anti-money laundering, credit risk analytics, and customer support. Okay, so let's quickly jump on to each one of them. Okay, so let me try to tell you each with one use case. So customer segmentation in banking. Just imagine that you are a bank with around 2 million customers. Okay, and you have around 200 personal bankers. Okay, right? So you cannot have one personal banker allocated to 2 lakh customers, right? So one personal banker cannot take care of 2 lakh customers. It is humanly not possible, right? By the time he starts calling, I think it will probably take 2 years for him to finish off calling for 2 lakh customers. So then how do I get it to the segment, right? So what the banks do is they demarcate their customers into different segments. So they term premium, medium or low preferred. Like say for example, you spend more than 2 lakhs from your bank account and you kindly pay back your credit card as well, then I call you as a premium customer. Then if you spend greater than 2 lakhs but you're still not paying it timely, but you pay it within the 30, 60 days or something, then you term it as medium customer. And then low preferred customer is the one who does not spend much and is not paying back the amount spent on the credit card also. So what I will do is, I will segment each one of the customers into these buckets. Just imagine you have to do it manually for 2 million customers. It's going to take a hell of a lot of time, right? So what the machine learning is going to do is that it's going to do it in a span of few seconds. Okay, so you're going to run a quick algorithm called classification algorithm. It's going to quickly classify the customers depending upon the spend and the timely payment. Here I have taken only 2 criteria, the spend and the timely payment. You can probably add dozens of criteria also, on based on which you need to classify the customer groups into different segments. So what it will give you is that it will give you 4 or 5 segments, and then what the banks will do is they can use their 200 personal bankers on what the customers would want to concentrate on. Like say, if my bank wants to concentrate on the premium segment, I will probably concentrate on the premium segment and allocate only the personal bankers for the premium segment. For medium and low preferred, I may probably have a different strategy to work with. Okay, so this is how banks classify different customers and segment them. You would have probably seen that in your credit card, they give you a platinum card, ruby card, gold card, silver card, and all this stuff. They are not helping you, but actually they are helping themselves so that they can classify the customers to different groups so that they can reach out to you easily. Okay, so that's one of the use cases where data science is used. Another one is the attrition or the churn analysis. Okay, so same bank, you have around 2 million customers, but if you have a small call center with 50 call center employees and 4 zonal managers, one sitting in Delhi, Bangalore, Calcutta, and Mumbai. Okay, so you have around say 15 employees in each one of the zones. Okay, in call center. Now 2 million customers. Okay, so just imagine the amount of calls that you're going to get. And how is your call center employees going to answer it? You need to automate the calls. The customers should be able to go through IVR system, okay? So they can auto resolve their issues for some of the simple issues like getting a bill and all the stuff. If they want to call, they can probably call it. And if they have to still speak to a call center employee, they can still call to the call center employee. But if you need to predict if my customer is going to leave me, how can I predict it? Based upon my call center records, if I am able to collect all the information of number of times the customer has reached the call center, number of times that person has made bank visit, number of times he has raised concerns, and number of times I have been able to resolve them, number of times I have not been able to resolve them, right? If I am able to have all these details, now machine learning is going to predict and tell you a given number, what is the percentage surety that this particular customer will leave you or not leave you. Then I can probably use my call center employees and zonal manager to concentrate on those employees who are having say greater than 70% of chances of them leaving me. Okay, so I will probably give them some offer or probably ensure that their concerns are mitigated faster so that I can retain them. Okay, so attrition and churn analysis is done in banks, financial sector. It's actually done in all the companies. Telecom companies also do it a lot. Geos, Apples, and Vodafones also do it a lot. So now almost all the IT companies are also doing the same kind of attrition churn analysis. Okay. So just for one of the customers that we did, you could easily see that the no churn were here and the churn was the yellow one. Okay. So we could easily see that people under the age of lesser than number of age with the bank, they were actually churning a lot, or rather leaving the bank a lot. So if they are there with the bank for 30 to 40 months, then they are leaving it a lot. And if they cross a period of around, let's say 40 months with the bank, they stay put to the bank for a longer period. So this company took a decision, started a decision telling that they will handhold the customer for the first 40 months, but they know that after the 40 months, they are anyways going to retain the customer for the lifelong as a customer for my bank. So they had a special program which ran called the 40-month program, where they were having people involved with them for the first 40 months so that they can increase the number of people who are going to stay with us. Okay? And this is one of the analysis for people to identify if who are the ones who can churn and who are the ones who cannot churn. So you see that there's a yellow pattern here, and distributed pattern here. So then the banks dig deeper into this particular group which were churning or rather leaving me, so that they can understand the profile of these people who are leaving us and try to see if we can improve the engagement with these people so that we can make them stay back. Okay? So that's one of the analysis. Another one that also is there may be different reasons why a person leaves the bank, right? So it's also important that you take that into cognizance. So some banks have high balance. So for this analysis, without taking the bank name, balance was considered to be the primary factor why people are leaving the bank. So they reduced the bank balance requirement for metros, and they were able to recover a lot of people who are leaving. And credit score. So they wanted to ensure that people with average credit score also are given some leeway, because credit score was given huge importance for people to be with the bank. Okay? And age. So this was also one of the criteria, and the banks decided to have a lot of lucrative schemes allocated for young people who are starting off accounts. So one of the schemes was to ensure that they tie up with the IT companies so that their salary accounts are tied up with the banks, so that we can involve a lot of younger population to open up accounts with the banks. Okay, there was an easier way to catch hold of the younger population for opening accounts with the bank. Okay, so those are good analysis, data-driven decisions that the bank took. I was able to revive the last 2-3 years. Okay, so next one. What is the time? I think we are at 11:40. So let's do 2 more use cases. Then I'll probably start taking cases. Questions from you guys. Okay. So probably I'll do it till 11:45, and then I'll probably start taking questions from you. So credit risk analysis. This is one of the most valuable use cases that is done. So I still remember times 14 years back when I used to go with my dad to one of the banks and apply for home loan, and I used to come back at least 4 or 5 times and wait for humongous hours outside for the manager to approve the home loan, right? So it still is me in my memory. But how has it evolved now? So almost banks are coming to your doorstep to give you the documents for signing signatures, right? And they are giving. So how has it happened? So what has happened is that there are a lot of changes that has happened in the process. Now there is no human involvement in approving or de-approving the loan. So based upon different criteria, okay, number of your civil score, the number of liability products that you have, like cars and other loans that you have, other kind of fixed deposits that you have in your account. So bank has an algorithm. So each bank has a different algorithm. So your algorithm is going to run, and your data science is going to tell you if this person can be given a loan or not given a loan, and if he can be given a loan, how much the maximum can I give him a loan, and what is the approves the loan or not approves the loan. Okay, so it's quite transparent now in the banking sector on who can get the loan and who cannot get the loan. Okay, so there has been a welcome change in the last 10 years, and we've been able to change the banking model around that. Okay, so profitability analysis. So like say for example, if I am from the bank and if I have to set the interest rate that I am going to give for the home loan, okay, so if I change the rate of interest to 8%, then how is my profit increasing? These are in crores. Okay, so is my so I can then plot and see how is my profit increasing. If I change it to 9%, how is my profit increasing, the red one, okay? And then if I change it to 10%, how's my profit increasing? So I can change and see how is my profit going to change for the next 5 years, and now I can take a call of what is going to be the right interest rate that I need to set for the bank for the particular month, right? So data science allows the banks to do that analysis. Okay. Fraud analytics, I think probably the last one that I would cover for the day. I'm not sure if you have seen it. I've encountered it when I was buying something for my wife in Tanishq some 4-5 years back. So I swiped my credit card and I got a call directly from the bank telling that, are you really the person who's making the payment? Yes, I did. Then they sent me an OTP, and then I had to key in the OTP to the retailer, and only then my transaction was approved. So I'm not sure if you guys have gone through it. They probably send you an additional OTP, an additional verification before they allow you to make a high value transaction, right? So why is that done? That is because banks keep a tab on what types of transactions that you do. Like say for example, you typically do in a particular area, like say in California, say in Bangalore, you want to do it in a particular region in Bangalore, and suddenly you say your transaction happens in somewhere in Madhya Pradesh or in Delhi, okay? And typically use your credit card for normal mundane things like grocery and buying parts and stuff, stationery goods and stuff like that. And you typically use and suddenly if you are going to make a transaction which is going to be completely different from your normal scope, okay? So this is your normal transactions, and if you make a sudden transaction which is going to be high value and far away from the location where you are typically make a transaction, then it's going to raise a red flag to the bank. Okay, so the bank will then have people call you and ensure that you are the right person who is making those transactions. Okay, so again, data science has enabled that to do it. So that's a process called clustering, where it tries to identify the outliers and tries to send out an alert for fraud alerts. Okay, same concept is used for anti-money laundering. It keeps a typical template, and any template which goes outside that template for any transaction that happens, which is going to be different, it's going to alert the bankers and also the sales scholars to take action on that. This is most likely a laundering transaction. So ED and the different departments have to take action on that. So that's how the banks are alerted. Okay. The final one before we move on to the Q&A. So the banks have been able to implement all the stuff that I have been able to talk to you now. Because almost all the banks are using this. So some of the banks that are taking it to the next step. So the Bank of America has already implemented this. Now they have come up with chatbots inside your phone apps. Okay, so any transaction that you would want to do, you will not have to log in directly to your system and then make transactions. There is going to be like an Alexa or you are going to have an Erika. And the voice assistant is going to help you make transactions, and it's going to recognize your voice, and it's going to be just like you're going to have your fingerprint for recognizing you, you're going to have your voice model technology to recognize you, and facial recognition technology to recognize you, and they are going to be used for authentication to make transactions. Okay, so that is something that you're going to see in the next 1 or 2 years. So I'm confidently able to tell that this is the technology that some of the private banks are investing in, and you might probably see it in the next 1 or 2 years that in the Indian market as well. Yeah. So before I finish it off, just like life, data analytics is also like a box of chocolates. And just like life, you might like few chocolates in the box and you might not like few chocolates in the box. You never know what you're going to get from that. So just like that, if you're going to allow the data to tell you what the results are, data is going to tell you what it really wants to tell you, and then you're going to use it for your analysis. And you can manipulate the data for your own good to make it to cater to your decisions, but that's why ethics comes in, right? So data will be able to tell you only what you would want to see, right? So always whoever is going to get into data analytics, that's what I ask them to do is always put your ethics in front of your data and allow the data to tell you what it wants to tell you, and then you take the decision based on it. Do not always keep few decisions on the back of your mind and then try to help the data tell what it wants to tell you. Okay? So with that, I wind up the session for today. Thanks a lot for this wonderful opportunity, ma'am. Thank you. I'm going to take Q&As.
Any questions, my dear students?
I think you're muted.
So, any questions, my dear students? No questions? So, complete knowledge on data science you've got? Yes? So, thank you so much, sir. No questions are coming up from students. Yes, everything is clear for them. As of now, I think anything more is there? Please tell us.
Thank you, ma'am. Thanks a lot for this wonderful opportunity. I was able to spend time with the students and if there are any questions, feel free to reach out to me. I'll be able to help you if anyone is interested in taking up the category later. Okay?
Yes, sir. Thank you so much, sir. Thank you.
Thank you. Have a good day. Yes.
Great.